Welcome, everybody, to Today in Space. We're back for the All Things Space Science podcast. I'm your host, Alex Girofanos, and we are here to combine two of my favorite things. Number one being space, as you know, and number two, 3D printing. Now, this week, we have two guests here, Greg Paulsen, Mike Cavalieri, here from Xometry. If you're in the 3D printing world, you know Xometry. It's no surprise. But for everyone else, we're going to hear more about that. But we're going to talk about space applications. We're going to talk about 3D printing in space. And that's a really important thing in my mind since we've started this podcast, is the fusion of those two things. It's why I started working for an industrial 3D printing company, was to work towards a future where those things are being fused and to work with the companies that are buying that equipment, because then by the third rail of that, I am also working on those applications in the space industry by helping them. I want to welcome both Greg and Mike. Welcome to the podcast.
Yeah, thanks for having us.
Yeah, thank you so much for having us.
Absolutely. So you guys are in my world. I would love to hear from both of you guys. Tell us about your origin story and what kind of brought each of you to Xometry.
Yeah, absolutely. Alex, first of all, thank you so much for having us on the show. We could not be more excited to be here. Had an opportunity to watch some of your podcasts recently and can see your passion for both additive and space. And it's exciting to bring these things together with what we're doing here at Xometry. But I'm Mike Cavalieri. I'm our Senior Vice President of Marketplace Operations here at Xometry. I'm a mechanical engineer by trade. Went to Virginia Tech. Started my career in industry, and I've been leading global operations for companies for quite some time, primarily in robotics and automation.
Hmm.
And some of those applications have made their way into space, whether it be lunar landers or Mars rovers, satellites for internet connectivity. You know, these are the kinds of applications that I've been exposed to in my career. So now, Xometry 2.5 years now, doing it a little bit differently, doing it with an AI-powered marketplace.
Hand in hand, staying up as late as the engineers have been staying up.
Yep.
And on their side, they're designing stuff. On our side, we're getting it fulfilled and made. And so it's been really great, kind of growing in the last decade plus. But yeah, my background. So I've been with Xometry since near the beginning. But before that, I was in ruggedized product development. So worked with additive manufacturing since around 2007 or so.
Wow.
And honestly, something that's unstated in additive manufacturing is the real gateway to 3D printing, which is CAD. So my
Yes.
origin story actually starts
Preach.
that,
Sorry.
yes, it turns out you can't 3D print anything unless you could 3D model or have a 3D model of it made,
Uh-huh.
which many people do not make that connection initially. Uh, but yeah, I started actually getting exposed to CAD while I was in high school. So we
Mm.
had a high school drafting where the first year was all benchtop, like those Danish
Oh,
drafting tables at an
yeah.
angle. You're learning how to write your eights correctly. Everything's inch tall and all that, and you're hand drawing your isometrics. And then I got exposed to was Autodesk Mechanical Desktop at that time, which was really the bee's knees for that 2000 time frame.
Yeah.
And that's when I started learning the phrase extrude, and I can make a 3D object. And I actually did CAD competitions and things through Technology Student Association at that time. So that really got my brain into thinking in 3D. And then years passed. I got a undergraduate in business, and then I wanted to work in the technology center or sector. So I started exploring what else could I do, and I went to grad school at JMU and got exposed to my first selective laser sintering machine.
Oh.
And so I ran SLS. We also had other manufacturing there, some injection molding, we had a product realization lab, Z Corp machines, which were
Oh,
kind of
the
like the
old
first
school.
color
Yeah.
ones, and Dimension FDM. But that was my first exposure. So that was right around 2007. So I essentially had like a 5 year no CAD period in my life, and then I got back into it, and I've been
Wow.
hooked ever since, working in this field. And I've worked across all sorts of manufacturing, and have had the privilege of working in a way where I get to see the results,
Yeah.
and which a lot of times is burning your hands on the stove. So my background as has always been in solutions engineering, and now I'm in category management for additive manufacturing. But
Mm.
it's always been around looking at design, spinning the CAD, figuring out the right material process to make
Mm.
what you want.
That's huge. Well, thank you both for that
Mhm.
intro. We've got some Serious overlap, and I think we can relate on a lot of things. My question for you is when you're starting with 3D printing and you've got a 3D model, a lot of the times you're getting it from something that was made with another type of manufacturing. And I think this is the case for 3D printing a lot. But whether you're making it from a mill or a lathe, and then you go to 3D print it, that doesn't mean that that same model made for a different machine is going to 3D print well. And while it may be very satisfying for someone to say, I have a model, make this, or I downloaded this online, I would argue that that's probably the point where most of the frustration that you're going to deal with in 3D printing starts. It's there, it's right at that moment. And it seems like the best ones are the ones saying, hey, check out this part. Why are you using this part? Just asking questions. What is it going to do? All those things are like so important to feeling the results and the ROI of 3D printing. Does that ring true for you
Yeah,
guys?
absolutely. I think you have to think about where you are in your stage. So, 3D printing has always ruled prototyping, rapid prototyping.
Mm,
And the question is this, where do you want to be in 6 weeks? That could be a rapid prototyping solution. Where do you want to be in 6 months, where I may be working in a bridge manufacturing environment, or I may figure out, hey, the way that I'm prototyping is the way that I can make this thing. And then
right.
6 years, right? My product's released, it's sustained and working through. So Xometry as a platform, so we have a digital manufacturing platform where you can upload your 3D files, get pricing and lead times. We're kind of agnostic on how you start. So
Okay.
we have plenty of options for plastic and metal 3D printing, but we also salute the traditionals, right? There's a whole bunch of stuff is CNC machined and made out of
Mm,
sheet metal, it turns out, or injection mold,
true.
and that's okay too, right? Additive's actually the underdog in this case.
Mm,
So we give a variety of options, dozens of manufacturing options that for customers to choose from. And really, that question of like when you need and what's your application can help us figure out solutions that the customer may not be familiar with.
yeah.
Yeah, I think so often for us, we start with the design, and our customers may submit the file, and they select a particular manufacturing application, and because there is so much familiarity with CNC,
Mm,
folks will simply upload their files. It hits our queue in our CNC application, and then we look at the model and we say, well, actually, this geometry is completely impossible to make in traditional subtractive CNC methodology. So we'll
yep.
go back to our customer and we'll say, hey, what do you think about using an additive methodology here? We can actually achieve some of the geometries you're seeking. Now there's some alternate challenges on maybe some different tolerancing you have in the product and feature, but you're
Hmm.
right, it always comes back to the design. That's where it all starts. I love the way Greg put it, as far as none of this is possible without the modeling. And then certainly, in the industry, maybe engineers that are maybe more accustomed with designing for CNC or designing for sheet metal fab, really learning the industry limitations of additive or what's capable with additive, and then modifying some of those design techniques specifically for this industry. But yeah, ultimately, I mean, it really starts with the design. What I love about being, here at Xometry is that we do have access to literally everything in the way that anything can be made.
Hmm.
And so if we're looking at a model and it can't be made one way, we bring in some of our experts and their different, technologies and capabilities, and we find a way to get it made, which I do think is a big part of why we have been so successful in partnering with some of the world's leaders in spaceflight applications.
Yeah, and Greg, you mentioned like the late night hours
Yeah.
for space, like, and that's a lot of different industries, especially the 3D printing industry. Like those extra hours, they're really, I don't think they're talked about as much. How many hours are really put into like making something, and for you guys having the wide, plethora of ways of making thing, it must be a 24-hour thing, just constantly requests and can we get this out the door tomorrow?
The digital platform that we have really helps, right? Because the internet doesn't
Right.
sleep.
Yeah.
But that being said, things like processing purchase orders and other deals, especially in the early days of Xometry, we would joke because Xometry started off in Gaithersburg, Maryland, so we were East Coasters. With that, you're dealing with a national time frame.
Hmm.
So a lot of my early days time was, working normal day. I drive home, I eat dinner. and then I process purchase orders from California. So it was just kind of normal. And as we've grown, obviously now we have staff on board in multiple time zones, and Xometry is now a global company, so we have staff all around the world. So that certainly helps. It's
Mm.
really nice when someone in Europe solves something, so when you wake up in the morning, it's already there and ready for you. Like, it's time zones really can work in your favors in that case. With our major aerospace players has been that we've had this empathy over time, working with them and their
Mm.
needs, and
Mm.
and we're right there with them.
It's huge, especially, I mean, the new space industry, the, you know, SpaceX's, the Blue Origins, the Rocket Labs, they are certainly not any less hardworking than the old space folks. So yeah, it's truly heroic efforts that happen just to get some of these parts out there.
No doubt, no doubt. It does not sleep, like you say, right? When there's a launch approaching or a deliverable, upcoming, our customers that, it is not unusual for a new design file to hit the job board or hit our queue late into the evening. And so, yeah, absolutely. I mean, we've effectively now deployed personnel in time zones around the globe to be able to process this work and keep up with it.
That's
And it's
amazing.
just absolutely astounding the number of parts that we're processing, what time of hours that they're coming in. Engineers don't sleep. When there's a milestone upcoming, it's
No.
Saturday, it's Sunday, it's 10 o'clock at night. And, so no, it is a around the clock operation for us now.
Absolutely. With additive manufacturing, I think there's two things that happen at the same time. It's this magical thing, right, that can make these parts that some other manufacturing methods can't make. But at the same time, it's not like it's replacing any of those manufacturing methods. It's another tool in the toolbox, if you will. How do you see additive manufacturing transforming the way that parts that are made for space, like how they're designed, how they're produced? I mean, you guys are at the front edge of the traditional and the new, additive manufacturing methods.
I mean, no doubt, right? Absolutely, it is. It has to. I mean, when you're talking space flight applications, the mission is always about having the right part that serves the application at the
Hmm.
lightest weight possible, right? And
Mm.
what additive enables is these complex geometries and wall thinning and hollowing out, honeycombing, the interiors of,
Right.
of, of certain components in a way that could never be done with traditional fabrication techniques. So in that regard, whether it's flights or if you're in like automotive racing, anywhere
Mm.
where light weighting is a critical application requirement,
Hmm.
additive is now a technology that really enables to get to a lighter weight component with the same structural integrity that you needed in that you need.
Right.
So similar to when carbon fibers or exotic materials came into the industry, just by necessity of this pushes the limits of what is engineering possible
Mm.
in the world. Additive is doing that, for the manufacturing process now.
Mm.
Yeah, and absolutely. And the one of the wonderful things is part consolidation. So
Yes.
uh, just reducing the amount of SKUs that you have to release for a product line, and taking a creative advantage of what I can do with additive to
Mm.
reduce things that can be thawed, like foreign object debris, within a system that's typically highly shaky. So
Yeah.
how can I reduce stuff from falling apart? Well, make sure that there's nothing to fall apart in the first place, and I think you see that most successful in rocket nozzles, right?
Mm.
When you look at the complexity of additive manufactured rocket nozzles and how they're built, kind of a nozzle within a nozzle. They're using computational design and geometry to build essentially digital twin models to make these, and then you can make it a
Mm.
physical reality only with additive, like
Right.
only with additive. Can't do
Yeah.
that.
Yeah, and with the introduction of AI now, you've got the hardcore computational physics that they're doing, and then you're adding in this other tool that can just do things faster than some of us or even some computers can do single tasks. It's really like kind of crazy. Like I think the best example, visual example that we have in the public eye is the Raptor engine. The development of that is truly, truly fascinating. I mean, you see how many cables and connections and the rerouting of the fuel to get to where it needs to be in time. And then you see how much it's reduced down to. And that, like, I would imagine, whether it's through a casting or through a laser sintering process, like that's probably how it was made. It's that final V4, you know?
Yeah, yeah, absolutely. And it's interesting because I'm learning a lot now in my career about pressure vessels, and it's something that I've been
Mm,
exploring, and just seeking to understand with metal additive manufacturing, what can you do with pressure vessels? And we're looking at like wire-based additive processes and
mm,
exploring those, and it's pretty remarkable. You see a very different way of approaching a problem that has been around for a while. In
yeah,
this case, I've looked at this the opposite direction, like underwater stuff.
right.
But it translates to things that are going in space, like things get hold of a pressure differential on each side of it.
Mm,
But yeah, just seeing that there are systems that are out there that are building and qualifying product, and the method of manufacture typically net overall is a reduction of time and kind of gets you more of like a just-in-time inventory of spacecraft or spaceflight equipment. So that's really exciting, and it's emerging. I mean, that's something where
yeah.
we're starting to see it, but we're seeing it in niche industries or owned by one company or other. It's not necessarily someone can go on Xometry right now and say, "Hey, I need to build, this XYZ pressure vessel," but that's a place where we can go,
Right.
because as you start seeing it, you start seeing suppliers who could do that, and what
Mm.
we can do is basically build that diversity of manufacturing within our ecosystem.
I love that. I was just gonna ask, like, yeah, how do you guys vet suppliers? Like, you've got this cool technology. Like, I'm sure you guys see a lot of hype, and then you've probably got this process of like, hey, how would we go about even saying we offer this as a service? I'm sure there's a long list of things that you guys do.
Oh, so how do we vet suppliers? So I'm here in our Gaithersburg facility, really where it all started for
Mm,
Xometry. But this is where we receive the very first components that any new manufacturer wants to fabricate for Xometry.
mm,
So part of the inbound onboarding process is we have test parts that we've designed that
nice.
really test your capabilities and knowledge and process know-how in
Mm,
that particular manufacturing techniques. So we do have one part for lathe, another one for mill, some parts for additive.
that's great.
And as a new prospective partner, you send this part in, we review it, we can see, okay, these guys, they know what they're doing, they understand how these parts are made. And then they start and we onboard them into our network. And then their first few jobs come through Gaithersburg, through our operations in order to verify that they're still making now customer components to the specifications that were required before we start releasing them to ship directly to our customers. And then we have ongoing performance management scores, quality delivery, the way they engage and communicate with us, and all of these things correspond to what level of customer access we give them. So you're not going to be producing
Mm,
components for NASA day one in our marketplace. You earn that right through a
right.
strong resume of execution with Xometry and some of with the most challenging specs and requirements. So that's really how we're bringing new partners into the network and making sure that they can produce to the quality standard that we expect.
And something that's kind of unique. So my role has recently changed into this role of category manager.
Mm,
And when we look at categories, we're thinking about them as right now manufacturing processes like CNC as a category. In my case, it's additive manufacturing,
mm,
and that is the holistic experience. So when you go to our site, what do you see on the menu? What drop down items do you have? Can you select and get priced out?
mm,
How do you engage with that? To the fulfillment side, what does our supplier base look like? Is it robust for this type of offering and the demand that we have for those offerings?
mm,
And working through that and end to end. And yeah, you'll start to see trends. So with our drop-down menu, essentially everything you see, we instant price. We can give you instant quotes for. But it doesn't mean that we're limited. I have 5,000
Mm.
shops. I can make parts, like,
Right.
we can make parts. So you never ask at Xometry, can you do this? I'm like, what are you going to do? Go to another shop? We have thousands of them. We
Right.
can do this. We may not auto quote it. So we start to see these
Mm.
demands under material or finish where people write other. Like they'll
Mm.
say other and they'll type it in. And then when they submit that request for manual review, it goes to our internal staff team. We have staffed experts in every single field. A lot of them have been shop or
Mm.
business owners in the past, and they're able to review that work and typically go and find pricing. And if we have that source on the network, we're able to reflect that back. I
Mm.
could take a look at that information and see, wow, a lot of people are asking for this thing that we're not offering right now. And we could start building momentum with our tech team to say, hey, this is the next thing that we should add to our menu. We're starting to see demand or large opportunity. We, I just recently found something where we're getting asked for something. And I was like, oh man, this may be hard to find. And it turned out one of our CNC suppliers actually, their real business is the thing I'm looking for. And they just happen to do excess CNC work for us on the
Wow.
network. And it was just like this aha moment as you start seeking it. So we have a lot of this talent built in. And in our,
Mm.
part of that job is just how can we express it so customers can access it? Like, how can I democratize that access?
Yeah. Well, what you guys are touching on is something that's really close to my heart in the country that we live in right now in America. Like, manufacturing. So I worked for an injection molding shop. That was one of my first jobs out of school. We were working on composite molding stuff for, I think at that time it was the F-35 Strike Fighter. We were trying to get a
Mhm.
bid. So that was very exciting work, hard work, but exciting. But I learned so much from those tool makers, from those machinists about like what it is to really make something, to end your day with something in your hands or something to show your progress for. Like that's such a beautiful thing. And what you're describing is like the nuance of all these people that are even though manufacturing is not a popular thing in the US, it is essential for anything. And so you're describing the nuances of what it is to be in that culture. You guys are in the manufacturing culture. You guys are connecting the loops, getting the jobs into, the parts into people's hands and connecting the manufacturers to the part wanters, I guess. How do you guys feel as your connection with just manufacturing in general? How powerful is that?
I mean, I think it's incredibly powerful. I think prior to joining Xometry and a desire to scale up operations, I was always in search of this large manufacturer, CNC shop or other that had this great scale and capability that I could just funnel tons of work into and rely on them. And what I learned through that process, and then further really reinforced as with my time here at Xometry is manufacturing in the US is small shops. It's small business owners, entrepreneurs that have their machine, maybe a few employees. And if they're very smart and successful and they start to build quality systems and controls, they grow to 10, 15, 20 people. And this is really where the heart of manufacturing is happening in the United States. And so with Xometry, what we are now able to do is bring quality controls and bring systems that really control quality and output of this network that enable some of these small manufacturers to gain access to fabricate for some of these, spaceflight applications, but under the umbrella of Xometry's quality control, systems.
Right.
And I don't think, if I think about my time in industry, searching out manufacturers that I would have even given some of the folks that get the opportunity to prove themselves in the Xometry network,
Mm.
the opportunity to fabricate goods for us, right? So I think that's really something special about what Xometry is doing here is really enabling access and quality control that really takes, helps our customers get capacity where they need it
Mm.
and our manufacturers gain access to the market that they wouldn't have otherwise been able to gain access to on their own. And Xometry is very much that bridge that is, I think, really empowering, American manufacturing. I think it's really quite special.
Mm.
Yeah. And I think if you talk to the staff internally, I mean, a lot of us come from this industry, right? We are like the best case managers, the best pod leaders that we have are, from traditional manufacturing industry. And even, for myself, I was just thinking, doing the mental math, like of my 16 plus years in advanced manufacturing, only the last 5 years have I not sat with the in a place where the machine is right across from the wall.
Yeah.
So I almost
Yeah.
missed the hum, missed the
It's a thing. It really
like that
is.
goes
Yes,
through,
it
like,
really
where
is.
it's true. Like you miss that machine noise, but we're constantly surrounded by that. So we get to kind of live vicariously through the success of our customers' projects, right?
Yeah.
But our day-to-day transaction is a two-sided marketplace. We're working with our customers, but we work with our suppliers just the same, and they have their own unique experience. We actually have, by the way, if you've got on Xometry site, we have our instant quoting engine, which is what the customers see. Suppliers have a different tool altogether called Work Center. So their Xometry experience is actually this
Mhm.
kind of supercharged MES, manufacturing execution system, secure cloud-based, where they get to their favorite page. It's called the job board, and it's like a Uber hail app, right?
Oh,
Where you
cool.
see how much you're going to get paid. You see your lead time, like when it's due, and this is one work. This is already like customer one work, and we're using AI to basically say, "Hey, Alex here. I think your shop would really like this job. This is how much you get paid. Here's when it's due. If you take it, you click accept job. That's an instant purchase order, no paperwork. It's just now you're responsible for
Nice.
timeliness and quality." And it feeds the beast, and we are able to kind of use those AI tools to kind of match, who does
Mhm.
what. If you love doing brass turn parts, you're going to start seeing more brass turn parts. If you're a DMLS shop and you're focused on, aluminums, titaniums, reactives, I mean, we're going to swarm you with it.
Uh-huh.
Especially if you're ITAR, by the way.
Right.
um
Absolutely. Yeah.
and so there's a it's something that it becomes routine.
Mhm.
If you've ever found yourself like scrolling an e-commerce app like at Amazon or something to see like what should I buy today, like if you see our partners or our manufacturers. I was on a call one other day, and he's like, Hold on a second, I'm about to take this job." Like, he's they're distracted by taking work and revenue off the board. Yeah.
Ah, that's incredible. There's no better feeling than
Yeah.
getting an order in for something you have to make. That feeling is
Oh
tremendous.
yeah.
So I can definitely agree with that. Man, it's such a cool thing that you guys are doing, and I think so moving into the AI space. So I'm also starting to work with AI and just 3D printing tools, things to
Mhm.
help solve problems that the industry hasn't been able to solve yet. So it's on top of my mind. And what you guys have is a database of parts of manufacturing, of who makes what, of who specializes what people are looking for. I'm sure that must have been so valuable to run through an AI to train off of.
Yeah, I mean it's a chicken and egg experience,
Yeah.
because when you start, you don't have any data.
Mm,
And when we started this late 2013, and we
wow.
started, and so like, yeah, we were in AI before LLMs. So I just want to say that out right now. But we've been doing this for a
Crazy.
decade, and we've been using machine learning and other, AI tools, to do two things, right? To provide instant pricing. So basically, you upload a 3D file, and you see that like we'll use computational geometry, interpret that file, extract things about that file, and
Mm,
say parts like this with this geometry. We'll say have two things. So like first off, parts like this with geometry are typically purchased in this process. So
mm,
it'll default to a process that we think you're going to order in.
mm.
And then we say parts like this in this process, and we're going to start at quantity one with standard finish and everything, cost this much.
Right.
And you'll see your pricing options right away.
Mm,
And then you could go and configure. You could change tolerances, surface roughness, materials, fully say, "Hey, I know you think I'm 3D printing this, but I actually, want to go and make it out of XYZ in this process." And you
mm,
could change your configuration from there and build it out. But yeah, all of that starts dynamically updating. But to your point, the feedback loop is when you press buy, we have to pay our suppliers to make it. And
yeah.
so, that's where the data training comes in. So we eat our own
Mm,
dog food. And over time, it like any training starts rough, but now
mm,
you're talking and going over, millions of projects. And
mm,
it's very smooth, for for these major processes as we're working through, and you could use some of those tools to kind of transfer learn. So if you're doing something
mm,
similar to something else, you can use some of that leverage to jumpstart your AI training and what's next. So we definitely do have an advantage when it comes to how our AI has built because we become a two-sided marketplace, so a self-contained system. It's
Mm,
different than there's some companies that have what you call a should cost model, where they have
right.
no skin in the game. And I've seen
Yeah.
that where they'll demo and be like, yeah, the sheet metal part should cost $12. And then in our mind, we're like, no one gets out of bed in the sheet metal shop for less than 150.
Right.
So
Right.
how are you gonna ask them to take that for $12, right?
Hmm.
Where when you actually have that information, you're able to give, a cost that is amicable both for customer expectation as well as we pay our suppliers, something that's
Mm.
reasonable.
Yeah, I guess Uber really is the best way to explain
Mhm.
Xometry's business because you're dealing with two halves of two different problems, right? The part owner and the part maker. Um, and yeah, I'm sure AI must have been real valuable with all the problems you guys had to solve to
And
make those things work.
and it's fast. I think one of the
Yeah.
problems that that people have, and you've probably had this in your career as well, is when you want to get something made,
Mm,
you have to wait.
yeah.
You have to send out your request for quote and
Hmm.
kind of just sit around and wait. And you may be sending out that request for quote to a few vendors, and all of them are responding at different times and asking different questions and giving you
Hmm.
way different prices.
Yeah.
I think our average quoting time happens between 15 and 30 seconds.
Well, and and what the traditional problem that we were solving is so often that lead time you would be quoted in a traditional quoting methodology was simply based on that shop's current capacity,
Mhm.
right?
Yes.
And
Yeah.
what Xometry enables is you're getting
Mm,
access to the machine shop or to the, manufacturer that has capacity right this second. They're hungry for work at this very moment
right.
and they want to fulfill the order, right? So I think Uber is a great, analogy as far as how does our marketplace work? Two-sided. You know, you have drivers and you have people that need rides. We
Right.
have people that need parts and we have people that like to make parts. And then I think where the AI takes over, I think what is maybe so much more complex and why AI is so much at the heart of what we're doing at Xometries is that complexity of predicting and projecting how much should it cost and how long should it take,
Mm,
everything from what material is it being sourced out of and readiness of that in the supply base. What are the tolerances that you're seeking?
mm,
How complex is this part actually to make? How many datums are you referencing that relational tolerancing from one part of the component to another? How critical that is to the design?
yeah.
All of these things really roll up and amalgamate into both lead time and cost. And getting that right requires just enormous amounts of data and learned history to be able to predict that correctly.
So in that data, you've had a lot of parts made. Let's talk about some of the space parts and applications that you guys have seen and can talk about.
We'll talk in generalizations, right?
Please,
Because
I
I'll
understand.
work. It's like it's one of those things. It's like I get so jealous whenever I go to like a OEM or additive machine manufacturer, and they're just like, they're showing this amazing, beautiful part. Like all our amazing, beautiful parts shipped to
You
the
can't,
customer,
yes.
and
Yeah.
then we don't ever talk about it. They may reorder it, but like mum's the word.
Uh-huh.
I I'll say like early on, we my first introduction to 3D printing for the space industry, it wasn't stuff flying just yet.
Mm,
But it was a really interesting application, and it required large format plastic 3D printing.
mm,
Um, and I've seen this and we see this years and years, and like it's a very common practice. But say I'm a satellite company and I'm building something, and eventually that thing is going to be very expensive, machined or turned components,
mm,
large format things and premium metals and alloys. The engineers still need to do fit ups
yeah.
with that. And some of the largest 3D prints that I've ever done have been for fit ups on on spacecraft and ships, and they're using those to take take that design and kind of articulate it up command, show what this is going to be, as well as actually seeing, okay, can I assemble it? I made it in CAD.
Yeah.
CAD's beautiful because you could actually make things pass through each other if you want to by accident. Can I put this together? Can I assemble this? Can I like when it's when everything's said and done, like does the cover and housing take care of this?
Mm,
And so we started doing that, and I remember like the first print job. We had to split and bond. We could print up to 3 feet. This thing was a little bit larger,
Yeah.
but I had a part like,
It's
my arms
crazy.
are spread out, and I'm like holding it over my head, like, look at this thing, and it's pretty fun. As you said, when you make a tangible good, it's very rewarding when you're done at the end of the day. But I will say, like, yeah, it's interesting. Like that was what I call assistive additive, right?
Mm,
It's very important for the development process space, but it's not necessarily the thing that is in the limelight. Getting
right.
getting out of the goods, but it's where you see a very large portion. Start with that assistive, and then you start working with, well, what can I do,
Mm,
on that craft?
Recently, we've seen a surge of various like drone applications. They
mm,
might be for
Mhm.
defense, they might be for point-to-point package delivery. You could probably think of some folks that want to get packages to your door as rapidly as possible, or even
mm.
or even getting medical supplies to hard to
Yes.
reach geographies. I mean, these
Yes.
some of the types of applications we're seeing. Could be anything from a bracket to the body skin to a nose cone. These are the types of parts that we see. We did have one recent application for a lunar lander where we made a titanium gold-plated sheet
Yeah.
to shield the lunar lander from the heat coming off of the nozzle. I mean, this wasn't additive,
Mm.
but the opportunity is certainly there for that to be an additive application in the future.
Um, Alex, I was listening to one of your previous shows, and you mentioned something that I think is really important when we talk about, flying things versus space flying things.
Mm.
And one of the things about space flight components is you can't land and fix it later.
Yeah.
And I think that's something that's really, really important because I mean we make things for aircraft, and it turns out, yeah, if it's we have that maintenance repair operations, a replacement part is okay, it's non-critical. They're gonna land, replace it out and go with it. And then when you are building something that isn't a spaceflight operation and not a non-landing thing like a
Mm.
satellite or something like that, I, the one of the challenges that comes in the decision making of can I grow this via additive
Mm.
manufacturing or should I build this in a more traditional method is going to be like the trust of that
Yeah.
object.
Yeah.
And additive is a little Wild West there. It's I can go to 1,000 vendors right now and buy 7075 aluminum and have a very high assurance that those material properties are going to fit my modeling. Like if I mill this 7075 aluminum to this shape, I'm going to have this results.
Hmm.
You're not gonna be like, hey, can you also mill ASTM test swatches of this and do all these things where you go and build out
Yep.
these sacrificial things because there's a lot of trust in that. Additive's different, right? You're not taking a larger stock and cutting it down. You're
Right.
taking a smaller component and building on that. And
Mm.
usually in metals and plastics, it's a series of welds a lot of times. And powder bed systems have a challenge where uh, part to part, even the same machine, same material, the exact same part profile, you may have slight deviations in what happens. So part to part. Now, it doesn't mean that those parts are bad in any way, but deviation means quality assurance, and it adds a lot of question marks at the end of it versus what we know, which is traditional manufacturer components.
Hmm.
So I, just going back to Mike's, like why someone on a lander may decide to go one direction or the other is that challenge. Like, if I can traditionally manufacture it, it may de-risk the project. But if I could add advantages in additive manufacturing, part consolidation, lightweighting,
Hmm.
inaccessible features, so internal channeling or latticing or some sort of internal structure that usually has a skin to it to
Right.
make it more robust. Like that's where additive really, really shines. And that talent pool to be able to go from there to here to there with that type of design is still pretty small,
Very
but
small.
it's growing
Yeah.
with better tools.
Yeah, man, you really hit it. The expectation setting that is so important in manufacturing, but definitely in 3D printing. Like you're using the same elemental components, but that doesn't mean that your part is going to end up the same. And one thing that I noticed in the metal industry for additive was and this was something that, I and many people in the industry are still trying to hammer home with people is like, before you even buy this part, let's talk about what you're doing, how it's going to be used, and why you're doing this. Because we don't want you to make the most hilarious example we used to get, and I'm sure you guys sometimes get this, maybe, is someone will send a cube or a cube shaped part and no internal features, just basically a block. And it's almost like you're testing the waters to see how much it's going to cost.
Yeah.
But right off the bat, like, oh man, like I've got to have a conversation with this person because we're not even on the same page of what I can give you. So like, what are you really trying to do? Um, if you're expecting the results of a machined component, like let's talk about the post-processing. Like, am I going to hit your margins here? Like, why wouldn't you go to a machinist to make that, right? Like, yes, tool setups are expensive, right? You set up the tool, the part to cut, then you have to set it up again. That's downtime, that's labor. Um, all of those things are the things you have to think about when you're making a part. And metal, so often you'd think, I'm buying 4140, but you're thinking I'm buying a machined 4140 heat treated part. You don't think of that, but that's your expectation if you're new to it. And that's a challenge in the additive space of getting over the hump of I want you to leave happy with this part. But anyways, the industry has a lot of work to do, I guess is what I'm
Yeah.
saying. And it comes with education over time. I don't think it's not like it won't be solved eventually, but we're still there.
And there are advancing capabilities, continuing to emerge, right, and become more and more available every day. I think one of the key challenges with additive is as you're building up this substrate, and if it's plastic polymers, you're applying a heat to extrude or a laser to sinter the material. And then, of course, with plastics, there's always a heat shrinkage, warpage effect that comes as the part is completed.
Mm,
This is a much different challenge than with subtractive technologies. Whereas, once you're done making the part and you can be as precise as you want, then the part can maybe distort at that final moment.
mm.
And
Oh,
some of
so
the
true.
emerging capabilities now that are really exciting, and I think will start to maybe really serve the aerospace industry and spaceflight industry, is these hybrid technologies.
Mm,
Where you're building up the substrate, right? You can achieve those impossible geometries with additive manufacturing techniques, laying down a laser, weld and building it up and, creating that honeycomb or lightweighting structure on the interior. But then another arm comes in with your CNC tool capability, cuts those final tolerancings, final capabilities. And now you have a hybrid technology capability that really matches the industry's expectations on precision.
yep.
And I think that's probably going to be maybe that next step that really enables additive to truly work in this industry.
Yeah.
Yeah. And I was going to say, like, one of the advantages that additive does have over traditional is it started digital.
Mm,
So it starts with a digital file, but we got to do better in an industry where right now the digital file is kind of like hanging down on its own. The processing and parameter sets that are typically combined with the machine making those parts are kind of doing their own thing.
mm,
And then the way we qualify those parts afterwards is kind of like its own set,
mm.
and they're not really talking through to each other. I think actually at Xometry we're kind of uniquely digital in the aspect that we are kind of cloud-based when we have our instant quoting engine, ERP and Work Center, and these tools work together.
Mm.
But on the additive side, I do sometimes roll my eyes when I see an additive company get a big amount of money and think that all they want to do is make equipment. I'm like, you should be investing in software and digital twin.
Mm.
Pre-deformation before parts. So can I create a predictive model of what my part's going to turn out to be after it's
Right.
heated and sintered through,
Hmm.
and how can I get closest to near net CAD when delivered?
Yeah.
And so it could actually, like, with better simulations, AI tools definitely can help achieve this and make it better and faster and more accessible.
Mm.
But how can I make it just part of my build setup where it's a click and go experience where it's the part is pre-deforming. So actually the feed file that's going into the machine is a different shape than the CAD provided, with it knowing that once all those thermals come in place,
Mm.
it'll set back into the correct shape at the end. And that's something where I see some wins here, and then I see
Mhm.
some wins over there.
Yep.
I don't see a lot of handshaking going across the industry, but it's additive because it's inherently digital is prepped better than most processes
Yeah.
for this type of future forward workflow.
Yeah. And we're at a really interesting point too. And this was something I learned from being in the injection molding industry is we've got a lot of people with a lot of knowledge and talent that want to teach. But they're at retirement age. And so what you're talking about is really like sewing the two fabrics of the generations together to be
Mhm.
like, look, let's like those M code operators, like they know what they're doing on these machines. Like there's no better uh subject matter expert to have there while you're building this, you know? So it's something I'm very passionate about is so at a shop in Connecticut, Westminster Tool, fantastic people, the Coombs family, they took care of me in my early years out of school. Um, they did a great job, and was able to have a hand in helping it of an apprenticeship program. And basically, it was bringing back the old days where when you were an apprenticed toolmaker, machinist, you were handed a book and you went through this book. Your mentor would check off, you finished this, and once you finished your book, you were no longer an apprentice. And we were digitizing that for them and making it so that both
That's cool.
yeah, it was very cool. And they still use it today, which is amazing. And what it's done for their culture and what it's done to give the teachers the opportunity to teach, the learners a chance to ask questions, and self-direct where do they want to go, right? If I'm more interested in, um, let's just say electron beam welding or something, I'm going to start going down that path. But you had that ability to do that. And we're in this, uh, what should I call it? This nexus point where manufacturing in America could not be more important after the pandemic and everything that's happening in the world, supply chain management. Um, and so it's on my mind a lot. And I think what you guys are doing to tie those things together is huge. Bit of a rant,
No,
but
you're on it. Yeah, you're seeing the world, so it's definitely true. And yeah, we appreciate we think we are at the forefront of where manufacturing should be, and we are digitizing and building access. Even what we find is when you build a marketplace like Xometry, you find a lot of shops that aren't making parts as many parts as they could. They
yeah.
have downtime. Spindles aren't turning, machines aren't running. And so the very first thing that happens when you build a digital manufacturing marketplace is you start building access,
Mm,
and it's a win-win. Like I think we eventually we do get to the point where our shops are expanding because of Xometry, right? They're buying machines and stuff.
right.
But the very first thing is we're keeping these shops alive. We're keeping payroll happening,
Yeah.
and it's because it's not a talent gap. A lot of times it's the fact that they don't have access
Yeah.
to the right customer and
Yeah.
the customers that want the type of parts that they do best.
Yeah.
And it's really cool to see those connections happen.
You're hitting on something that was such a lesson for me, and having a small 3D printing shop myself at home, like it's you get tsunamis and you get droughts of work, and that's kind of the challenge of a manufacturing shop is how do you fill in the gap? How do you prep jobs? How do you raise the flag to bring in more work before slam your workers who are already working double shift just to get jobs done? You guys are giving people an opportunity to raise that flag to a group, a community of people that are looking for parts to be made, and you're letting them turn it on and off whenever they need it, which is pretty
Yeah,
cool.
it's a phenomenal way to fill those valleys between demand. And then, as Greg said, I mean, we have many manufacturers in our network that are building their business with us and expanding, but it all usually starts with I have peaks and valleys in my normal customer demand profile. How do I fill in some of those valleys? And then you start to realize, oh, this is an amazing, marketplace. I don't have to go and find all of my customers on my own. Xometry just brings me this endless, demand that I can help fulfill and do what I love doing most, which is making parts, however it is that I make them in my particular shop. And then I think you hit on it a little bit earlier we are in this little bit of, generational handoff here, right? And when we have traditional manufacturers that are retiring, starting to close shops, and they may have been serving a particular industry or application for 30, 40 years, and the parts have never been resourced.
Yep.
And all of a sudden now the customer is saying, holy cow, this was a set it and forget it. I haven't thought about how to make this
Oh,
part in forever.
yeah.
And now I need to think about where it's going to go get made. And, Xometry obviously is in a great position there to be able to pick that up and find new partners and folks, that are doing it in a more digital era, right? Okay, let's go convert that 2D drawing into a 3D file. Let's maybe
Hmm.
scan the last part made so that we understand exactly what was being produced before the end of the prior supply, and really bringing the manufacturing process back to life and giving another, lifespan for as long as it's needed for our customers.
Yeah. Sorry, go ahead, Greg. It seemed like you were gonna jump in there.
Oh no, I'm just nodding vigorously to Mike's statements here.
Yeah, same here.
It's so true. The other one thing with the shops is we're also reliable payers. So sometimes when you work with the larger
Uh-huh.
companies, they start trying to force on you net 90 and net 120s. And if you're a small shop, you're like, I can't wait 6 months to get money for this. So we also do build a income rate, which is really important, going full circle to what America's manufacturing base really looks like, which is small businesses. They need payroll, and
100%.
we really do help support that.
I love it. But guys, this has been an amazing episode so far. I feel like we could do a whole other one. So if you're up for it, I'm totally down for it.
We're
Um,
always willing to. It's exciting to get a chance to talk about what we're doing here, and certainly with somebody that's in the industry that has the passion that you do. So, really appreciate the opportunity.
Yeah, absolutely. Thank you both so much. So, last words, I guess, for anyone out there. Usually when we do these interviews, I leave the kind of last words to you guys. And, if you're thinking about anyone that should be thinking about Xometry, about getting into the business, maybe working for you guys, whatever you guys think, the floor is yours.
Yep. All right. Well, first off, Xometry, it's free to access, right? So we get paid when you make parts with us. So Xometry.com, if you go online, if you have a project you're looking at, try us out. Try out the Instant Quoting Engine, take a look at it, explore materials, and explore processes. My previous role was in writing a lot of technical content for application engineering, including design guides and other tools. Like I said, nobody knows 2 dozen manufacturing processes back and forth, but we have a design guide for everything. So if you go to our site, click on our solutions page, you can go and look at all these different 3D printing processes, machining, molding, you name it, and click through. It's going to give you all this information about materials, and you can download design guides there. But we want to educate our customers to have better expectations about the process that they're choosing and really get the most out of manufacturing. So beyond just getting parts made, we have so many resources available.
Really well said, Greg. I think, whether you're a customer that needs parts and, give us an opportunity to upload your model and just be amazed with actually how easy it can be to a manufacturer, fabricator, and the opportunity to see the opportunity to make parts. And like we said earlier, fill some of those gaps in your own demand pattern. And then I would say for any, whether it's customer service, product technology, software development, or engineering, if you are looking for a career opportunity that is exciting, I think one of the things I love about Xometry is the breadth of innovators
Mm,
that we get a chance to see and talk to and learn about their applications. And like we have a front row seat to the world's innovation, right? Like we get to see everything that everybody's working on, pushing the boundaries of what technology is capable of doing. And when we're lucky, we get an opportunity to really sit down with someone that is trying to make an ultra complex part to serve an application that has never been served before, and we learn a little bit about what's going on in the world and what the next frontier in space flight or other industries may be. And it just couldn't be a more exciting place to be. I mean, I'm an engineer, right? I love to learn about new technologies and new capabilities and what people are doing in the world, how things are made. So maybe it's a little bit more exciting for me than the average person. But if I think if you're in the industry and you have a passion for manufacturing and technology, what an exciting place to be at Xometry. And we're so excited to be here with you and share our story.
Absolutely. Well, thank you guys both for coming on, for sharing your story. Folks, thank you so much for joining us for another episode of Today in Space. Stay curious, spread love, spread science, and we'll see you next time on Today in Space. See ya.
Thank you,
Thank you.
Alex.